Okay, thank you. Thank you everyone for joining this session and listening to this talk. I first want to thank the organizers, Damir and others, whoever is maintaining this group, because PASS ceased operation in January 15th, as most of you probably know. So initially there was a vacuum of training in the community and having the sessions and seminars. But it's good to see that many groups are back into the operation, and leaders all over the world stepped up and arranging this kind of sessions. So and there are other ones you can look up. So let's move on. So my goal is probably talk about half an hour, a little bit more, and then also show a couple of demos. I know this is being recorded. I'll also send a link to the organizers from my GitHub repo. I'll refresh it, and then you can download this slide and also all the code that I'll be using for demo. Feel free to use it, test it, or play with it. If you have any question, comments, I'll give you my contact so you can come back to me. Or ask me further questions or follow up or any comments you have. So I'm not going to read details about what I do and what I've been doing. You can search it if you're interested, but I want you to take a note of my contact address on the left. So if you want to reach out to me later on, feel free. You can use any of this, Twitter, email, LinkedIn, or there is a contact page on my blog post website. You can go there and contact me from there too. I don't know what Damir prefers, but if you have any question, please put it in the chat. I can stop anytime. I do not have any thing that I have to finish the presentation before you can ask me a question, and please put it there. I'm not monitoring right now, but later on Damir can stop me and read the question back. So let's I rather answer your question than just keep talking about myself. So please feel free to stop me anytime. And if I do not know any answer, I'll make sure that I can take a note. I can reach out to folks and get answer back to you later on.
Yes, I will stop you right now because I didn't see the GitHub URL in the email. So can you please send me later, or maybe put it in the chat now, or how you prefer?
Normally I refresh with the newer slide and code after the presentation, and
okay.
I will email it to you, and you can let the team know. But I can show it to everyone where it is.
No problem.
Link. Yeah,
I will put it on the user group page. So sorry, thank you.
No problem. So before I dive into the talk, just want to give a layout of what you will be talking about. I'll first talk about few definitions in case if someone is not aware, and definitely we're talking about cardinality estimate. So what is a cardinality and why does it matter, right? Why should you even listen to me talking about this for an hour, right? What is the impact of cardinality estimates when we are executing the query? So I'll talk about that a little bit more, so you can appreciate this talk and why you should be listening to it and why you should pay attention at your work about this subject. And then we'll also talk about how the query engine get this estimated number of rows. One of the sources is the statistics, but there are other not everything is in statistics, right? You might not have indexes on everything, or you might not have stats on every column. And there are situations, there are operators, or there are predicates that we use. Sometimes SQL Server really cannot use the statistics directly. And how does SQL Server estimate the number of rows during those situations? And I call those as a magic number. They're really hard coded into the engine, and we'll look at a bunch of examples of those. So let's talk about definitions. So the first one is a predicate, right? And predicate we all use whenever we are writing TSQL. And predicate is it's an expression. It can evaluate to true, false, or unknown, right? In this three category, there are two different kind of predicates. One is a join and one is a filter. Even within the filter, there is where and having clause. So let's look at an example, right? This is a pretty simple selected statement joining two tables, orders and customers. The first one is a join predicate, right? Because we are joining using the customer ID between the both tables. Then in the where clause, we have another filter predicate with a date. And down below, even probably most of you know, once you group by, you can also put filters on your group by. So here I'm grouping by, but then I'm saying that, if the count is more than 2, then only give me the result. So there are all three predicates are in this example. Now we talked about predicate, but cardinality estimator also must determine how selective these predicates are. And when I say how selective, what does that mean? It means the fraction of rows from the input set of the predicate that will satisfy that predicate, right? So if I submit 1000 rows, how many of those 1000 rows will satisfy my where clause or one of my filters, right? That I just showed you in the previous slide. So it's the number of rows divided by the total number of rows. Now, why is that important, right? Because based on that selectivity of that predicate, SQL Server engine or the cardinality estimator and the query engine will make many choices, and we'll talk about those. So this is an example. We are saying, give me a count of number of orders. But then I'm saying when customer ID is equal 577. So there's total 73,595 rows, but out of those, only 577, only 75 will qualify in this case, right? So as you can see, if we divide this is 0.0010. Because now why it's important, right? The SQL Server Query Optimizer is a cost-based engine. That means if the select query have a low number of rows, so the cost will be lower, right? And if it's a higher number, the cost will be higher. And based on that cost, SQL Server decides which plan to execute, because when it's creating those plans, it looks at many different combinations of plans, many different flavor of the plans. The one with the, I wouldn't say lowest, but reasonably lower cost and give us the accurate result set is the winner. So that's why this is important to know how many rows are going to qualify for each operator. And when I say the cost of operator, there are really two things. One is the number of rows that will qualify. Other one is the kind of operator, right? So a combination of those two actually dictates the cost of individual operator. And when you add all the cost for all the operators in a plan, that's how the total cost is decided. And then it compares with other plans and then decide which one is to put in the cache and then go into the execution phase. Next one is the density. So in a simple English, it's how often the duplicates occur, right, in a column. And as you can see, I put it in the slide. And how do you know how much is the density? 1 divided by the number of distinct values in the column. So this is also another important factor. So if we have to take an example, again, going back to the orders table, there are 663 distinct values, means that's our density. And density will be used in many, many places during the estimation. We'll look at that, in different examples. So we talked about these definitions. We talked about cardinality. Now, what's a cardinality estimation, right? In SQL Server, before a query gets executed, it goes through a couple of phases, and we'll look at those briefly. Now, whenever it's a plan is submitted, or sorry, a TSQL statement is submitted, it has to first estimate, as I said a few times, how many rows are going to qualify. And we call those estimated number of rows. They're really estimated cardinality. And once the query gets executed, oftentimes we'll see that our estimated number of rows and the actual number of rows, which is actual cardinality, are not same. Ideal will be if the estimate was 100% correct, means estimate and the actual number of rows are same, but that doesn't happen. And why it doesn't happen? There are many different reasons, and I'll talk about some of those. So if we look at this is a picture from a execution plan from one of the cluster index seek operator. As you can see, in this case, our estimated number of rows were 7.68, but our actual number of rows are 12, right? So in this case, maybe it's not a big deal, right? 8 rows or 12 rows really doesn't matter that much. But imagine if these are in millions, right? Then you have a problem. And why do you have a problem? Let's look at some of those. So whenever we submit a query, first it goes through a parsing phase, right? And parsing phase means it get parsed and a logical tree get created. In the transformation phase, the query optimizer produces equivalent variations of the tree. It look at what are the other ways I can execute this query. And after that, it goes through that cardinality estimation phase that we've been talking about. Means for each operator, it tries to decide how many rows are going to flow through each operator in each tree. And based on those numbers, it put a cost for each operator and then of course add this. Once it's done, then it compares cost, right? We are in the fourth one. And after the compare cost, it looks at the lowest one and then it put that plan in the cache. Now, why does it put in the cache? So next time if I'm calling the same query, and if the hash of that query matches whatever plan's already in the cache, it doesn't go through that first 4 phase any longer. It directly goes to the execution, right? So that saves us to compile the query. That's the correct term every time we submit, right? Take an example. You go to a doctor's office. The office open in the morning. The first time patient comes, they ask you what's your last name and date of birth, right? They look you up in the system. Then the next patient comes. Do they need to really go through this all 4 phases for every patient comes in? No, because this is the same query. It's just a different parameter value, right? So once that plan puts in the cache, then it goes to the execution phase. Now, what will happen if that cardinality estimation phase is wrong? If I estimate wrong number of rows, right? Then all the 3 phases down the road get affected, right? Because our estimation is wrong, our costs are wrong, and we make different decisions, and it's a slow query. And it might not be a slow query, but it probably getting excessive resource it doesn't need, or it's getting less resource that it could have used, right? So ultimately your throughput and your concurrency get affected. So let's look at a couple of specific examples, right? So based on the cost of the operator and then the plan, and there's 2 more settings in SQL Server. One is called max degree of parallelism. Other one is called cost threshold of parallelism. So if your query cost is above that threshold, then you go parallel. And when you execute this parallel, how many CPUs or how many threads can work in parallel for a single operator based on your setting on your cost threshold of parallelism. Now imagine if I have wrong estimates, a plan that could have gone parallel and execute faster, now it's going to execute serially, so I'm going to take long time, or vice versa. If a plan could have just nice or enough for a serial execution, now it's going parallel. What does that mean? It means it's now grabbing more CPU than it didn't need to. So it's a waste. Now the other queries will suffer for that, right? They'll be waiting for, in the runnable queue to get the CPU. Memory grant, same thing. You can get more memory than you need, or you can get less. And when you get less memory, what happens? It will spill to the disk. and so you have to write the pages to the disk, you have to sort it there, then you have to bring it back, right? So you are wasting your memory, means some other queries are waiting for the memory grant. And again, so it's both way, right? So, and if you are getting more grants, but you're not using it, that's also a waste. Now, in SQL Server 2019, I want to make it clear, there have been some improvement. There's a new feature under intelligent query processing umbrella. It's called memory grant feedback. So look at it. SQL Server will try to make some adjustment if it sees that you are granted less memory or more memory. And I'm not going to go into details, but there have been some work being done in the recent edition. Whenever SQL Server go and do and look up the data, it has different access methods. It can do a seek, it can do a scan, or it can do a combination of seek and scan. Now, how does SQL Server decide that? Right? What do I do? Do I do a seek, a scan, or a seek plus a scan? Again, based on your estimated numbers, a number of rows. Joins. There is 3 different kind of joins: nested loop join, hash join, merge join, and there is a newer one in 2019 under intelligent query processing called adaptive join, which is really a combination of either it's a hash and a nested loop join. Combinedly, it calls it adaptive join, but underneath it's really only the three different kind of joins. If there is an aggregate operator, you can do a stem aggregate or a hash aggregate. Sort, again, we talked about it, in memory or in TempDB. All of this get impacted with your cardinality estimation. So why do this go bad, right? Why does SQL Server cannot estimate accurately, right? Why we are even talking about it? So why can't the engine be smart enough, right? So there are a couple of reasons, as you can see here. Number one, we do not create statistics on every column in our database. We do not create indexes on every column. And even if you create an index with a couple of columns, your histogram is only get created for the leftmost column. Still statistics, right? So if you have a billion rows table, you're not going to go and say, update stats with full scan. That's just not possible every time. Plus, once you are created statistics or you update statistics, now, your business is running, right? People are going to insert, update, delete. So the more data is being changed, the information in your statistics is less accurate, right? And then you have to go and do it again. We talked about samples. Other thing we'll see is that, or you might be aware, in the histogram, doesn't matter how big is your table, you only get 200 steps. So even if you have a table with 2000 record or 2 billion record, you cannot get more than 200 steps in your histogram. Parameter sniffing, and there are some out of model query constructs that we use, like table value function, table variable X query, and some of these are being worked on. If you look at the intelligent query processing family, there are mainly 7 features. Microsoft is actually tackling some of this, the table variable and some of the functions stuff. They're rewriting how things get compiled and how the query plan get impacted with this kind of construct. So there have been some improvements are happening, but not 100% there yet. So I want to spend a little bit, good amount of time explaining the output of Dbcc show statistics. The reason is that this is one of the primary source, or the histogram is the primary source of estimated number of rows or the cardinality estimation when the plan is getting generated. So I want to make sure that all of us can read this and interpret this data accurately. So I'll definitely request everyone, if you did not understand what I'm going to explain now, please stop me. I can go back and explain again, because unless you understand the output and how the histogram is created, you will have a hard time to understand where the rows are coming from. Because my goal at the end of this talk, when you look at execution plan and you look at the estimated number of rows, you clearly understand where is this number coming from, right? Then you look at your actual number of rows. If you see a huge discrepancy, now you know where it came from. Maybe you can do something to rectify it. Sometimes you won't be able to do anything, and that's also good to know that it's not in my control. It's hard coded into the engine. Maybe I can write the query in a different way. That's a different talk. But at least if I know the source, I'm well educated, and then I can do something. But if I have no clue where this number is coming from, it will be hard for you to fix it, right? So Dbcc show statistics have three different sections. As you can see here, I'm not going to read this because we'll look at it in detail. So the first one is called header. As you can see here, I'm not going to read all columns, but I want you to take a note here regarding rows sampled and unfiltered rows, right? As you can see, the unfiltered rows is 73,595, but the rows and rows sampled are same, 50,299. So what is this telling me? This is telling me this is a filtered index, and you can see a filtered expression with the contact person ID greater than 2000. So you can also have indexes with filters. But if there was no filter, then you will see the rows, and it will tell you that it was with 100% sample, and you will know by looking at the number of rows and the number of rows sampled. Right? Oftentimes, if you just built it with the standard sample, you will see, how many rows were used during the updated stats. And of course, you see the date and time it was last updated and the kill. And there is a deprecated column. I highlighted it just so you know, don't use it. There is another place to use. So the density, you should use it from here or from the density vector. And they create a density vector for all combinations, starting with the leftmost column and the next two column, and if you have more columns, it will list all those in this in those groups. So this is the histogram. So this is the most important part that the query optimizer use to estimate the number of rows for each operator. And again, as I said, I'll mention this again, not every time it will be able to get a number from here. In those cases, you call it heuristic, means it will estimate a number of rows, and it's really not estimate, it's actually hard coded into the engine, and we'll look at some of those. So the two lines that I highlighted with the red box, I'm going to zoom that a little bit for you, and I put that at the top. So we are looking at two consecutive rows in the histogram, right? So let's look at the left. So the left is our values from the leftmost column of the index, right? So that's the key column or key values that the histogram is built on. So we have two IDs, 2083 and 2091. Now, if we move to the third column, if you see equal rows, since we did this with 100% sample, SQL Server exactly know if I'm doing a query with that ID 2083, it knows exactly I have 119 rows in this table. Same is true for 2091. It knows exactly 106 rows if my ID is 2091. ID or contact person ID or whatever it is. Now, what happened if I pass 2084 or 2086, 2087? So for anything between 2083 and 2091, what kind of information the histogram is producing? So first one is a range rows. That's the second column I'm talking about, the number 332. It is saying that between 2084 and 2090, I have total 332 records. It doesn't tell me for which ID how much. It just tells a sum of number of records for ID from 2084 to 2090 is 332. And if you look at the fourth column, it says distinct range rows. What does that mean? It means it's saying that out of those 7 values, I only have 3 IDs. Which 3? I do not know. So if you divide 332 by 3, it's 110.66. So you can see right off the bat, right? Even though we did a full scan, it's a small table. Now, if you pass a value, anything between 2084 to 2090, SQL Server doesn't know exactly how many rows you have for those IDs. Because only out of 7, only 3 has record. Other 4 even doesn't have anything. They have 0 record. But even if you pass those, it will estimate that you have 110 records. So I'm going to pause here for a second. Let me look at the chat. Does anybody has any question here?
On the chat, no.
Yeah, I'm not seeing anything. So folks, please, if any question, this will be a good place to ask before I move further. Because I have a strong opinion about this, that people should really understand how to read a histogram. That makes a lot easier when you are looking at a execution plan. Okay, so hopefully everybody understood. So that's all I have for slides actually. No more slides. So I'm going to go to demo. I'll show you a couple of these things. I don't need to read those. We'll look at this when you go to demo. And I'm also going to talk about multiple predicates, parameter sniffing, what happened when it's unknown. And I picked up 2 examples for parameter sniffing and ascending key problem because they are very common that folks working with SQL Server you come across. That's why I picked those 2. I'm sure there are other many cases that I could talk about, but hopefully after these demos, you have an appreciation for to understand where the rows are coming from. For my demo, I'll be using SQL Server Management Studio 18.8 and SQL Server 2019 CU9. You can also, if some of you are fully transitioned to Azure Data Studio, the execution plans are available there. You can also use that. So let me move to the demo, share my screen. Hopefully you can see my management studio.
Yes, all okay.
Great. So this is a setup script. I put enough note that you can download this backup from GitHub and then restore it. I'll be using compatibility level 140, the default compatibility level 140, which is for SQL Server 2017. And between the demo, I'll switch to 150, which is the default for 2019, a few times, just to show you a couple of the new features. And I'm also using the compatibility level, for that. And so I already, let me run this again. This takes in my laptop about 18 seconds. In between the demo, I'll probably run this 1 or 2 times just to reset a couple of things. And once it's done, I'll move to the demo. So one thing, I'll be using a lot of, pretty much everything is, all the demos are going to use execution plan. If some of you are not familiar with SQL Server execution plan, maybe a little bit difficult for you to follow, but I'm sure you'll get some use of this talk. But if you're troubleshooting and looking at this kind of things like why the estimated number and actual number of rows are different, you really need to understand the how to read an execution plan. And the best resource I can mention is there is a book by Grant Fritchie, who is a fellow MVP, works for Redgate. Grant Fritchie has a book on execution plan. I think it's over 800 pages. And because of the Redgate's sponsorship, you can download that for free. If you need a actual book, you have to pay for it, order it. But if you're happy with the PDF copy, you can download. And there's a lot of blog posts from many people about different operators, and but if you want to get a methodical reading of from step one, from step zero to a higher level, that's the book that I find very useful. Okay, so let's move on. So this one is a single predicate, and I'm using the wide world importers. There are two different kind of execution plan. One is estimate, like I said, that gets into the plan cache, and there's the actual one. The difference is in the actual one, you get a lot of you get all the actual runtime statistics, right? If you look at a estimated execution plan, you only see the estimated number of rows. When you look at actual plan, you see both, right? Because it only know the actual numbers after you really execute it. Now, how can you turn execution plan? By Control M. And if you want to know, in SSMS, okay, Damir just put the link for that book. Thank you, Damir. So if someone wants to grab that book, the link is there. This is a button that you can turn on for actual execution plan, and there's another one to turn on estimated execution plan if you don't want to run the query. So I'm going to turn this on, and then let's execute this. So now, if you see this, our estimated number of rows 89, actual number of rows also 89, right? That's the ideal. That's what you want. But does that happen every time? No. So let's look at our query. It says contact person ID equals 25, right? I'm going to take this, open a new window, run this. And look at this row 5. Let me know if it's not big enough. I can. So when you submitted that query, it says the contact person ID is 1025, went to the histogram, and it found a range high key. And as I explained before, under the equal rows, right? It straight goes and see this 89 and grabs the 89 and use that, right? Makes sense. So our actual number of rows and estimates matches. It's 89. Everybody's happy. So you update your stats 100%. Your stats is pretty good. Now someone comes and do some inserts, right? So I'm inserting another 2,800 records with the same ID. So what will happen now? If we go here, just take a note of this time. It's 11:32 my time. I know you are 6 hours ahead of me. After that insert of the 2,800 records, did it get updated? No, it did not. Nothing changed. As you can see here, it's still 89 rows. So I'm going to clear the cache just to be fair. I'm running the same query, exact same query now again. Look at this. It was 89, right? So where is this 92 coming from now? Because we looked at here, this didn't change. So is the engine not looking there anymore? So SQL Server try to do some scaling as you insert, even though your stats is not updated again. And it takes that 89, divide by the total number of rows, and multiply by the number of new rows. And you see this 92.33. And that's how we got this number. Of course, it's nowhere close to the actual number. I'm aware of it. It's 2,800 versus that. But at least it tries some, try to compensate for a little bit. Now let's pass a different ID, 1057. I need to, let me reset things back. Because of that insert, things get a little bit out of order. So I'm going to reset that to continue further. Yeah, once that is finished, then I'm going to run this again. So this one, 1057, what will happen? So let me close this. If you come here, so 1057 falls in between, right? And as we explained before, whenever anything falls in between, it looks like the next one, 356 divided by 3, we should expect a 118.6667. So let's run this. You see that number? That's where it came from. So any question at this time? Is everybody clear where that number came from? Okay. Looks like everybody is clear, so I'm going to move on. Now, the distinct values, right? If I say distinct of a column which has a histogram for, so we saw that contact person ID has a histogram, right? We already, we saw this here. Now, what will happen if I say give me the distinct values? See, the actual number is 663 and the estimate is 663. So how does SQL Server knows that, how did it decide that it has 663? 663, that's where the density come from. That's why I said the density will be used in many places. We'll see more examples of where density get used, right? So distinct is it's just using the formula that I showed you in the slide. That's what it's doing. So you're done with the single predicate. Next, I will do the multiple predicates. So for some of these examples or in the demo, you will see a lot of code in the comment section. So just to give you a brief background, in SQL Server version 2014, the Cardinality estimator was rewritten by Microsoft since SQL 7.0. So a lot of things got changed, right? As I'm demoing you in 2019 and 2017, but if you have SQL Server 2012 and hopefully no 2008, you will see different numbers in my demo. So I try to put code, if someone has an older version, how things are going to look like. Also did some comparisons. So I'm not going to run some of these. As I said, following section shows how the calculation is done pre-2014. So I just want you, if someone has it, if you're interested, you can go and take those code from the comment section and run it. So we looked at a single predicate. Now, oftentimes, that's not the only way we run TSQL, right? Oftentimes we have, we'll do a combination of, like 2-3 tables, or we'll do joins, we'll have other operators. So let's look at some of those. Now, every time we use something like this, right, in between, it's a range, right? And what does that mean? It means it's going to use many steps in the histogram, right? Because I can have a range, say, like I can say between 1043 and 1074. What happens during that time? The calculation is a little bit complex, especially to the age at the beginning and at the last one. So I put enough comment here. If someone wants to follow through this example, I put all, what happened during the edge case and the middle ones, and I did some math here. I also put two URL from Stack Exchange that I had. Also, I had a couple of email conversation with Paul White, who blogs in SQLperformance.com. So go through this. Hopefully it will make sense. If it doesn't, please reach out to me. This pretty much explains that when I run this, I know the estimate is 342.625, and I kind of explained there that how number got generated, right? Where is the how the cardinality estimator is getting that number. Now, same here. If you run this, it will estimate this, but then I combine these two, and let's talk about this. So when I combined, this with the end, what happens? SQL Server gets this number. Now, where does this number coming from? So let's look at it into a little bit more details. And again, there was a change made in 2014, and I want to make that clear. So as you can see that we have one section here and one here, right? For customer ID and contact person ID. And if you remember in the slide, I talked about selectivity. Now, why selectivity is important? It's important because how these things work. Look at this. So pre-2014, doesn't matter what your selectivity was, everything got the same weight. So, it will get multiply with the cardinality C and all the selectivity. But in 2014, there is a major change, right? And they call this, in mathematical term is exponential backoff. Means if you're the most selective, you get full weight. If then next will square root, the next one will do square root to square root. Means, it has less impact into my estimation. So let's run this. As you can see, SQL 2014, we saw the estimate was 44. If you ran this same query in pre-2014, your estimate will be 4 point something. And this is the actual row number. So definitely improvement, still not close enough. As I showed you, right off the gate, you never, most of the time you do not get the, 100% match. Now, some of you might ask me, is it always going to get better in pre-2014? I cannot guarantee that, right? There may be edge cases that things will go other way, right? That's possible. So we did an AND here. Now let's do an OR, right? Which is, the proper term is a disjunction and this is a conjunction. Here we get 1404.8, right? Where is that number coming from? Again, it's the same thing. It's a little bit different formula for OR statement, but again, before it was getting all same weight, but that's not the case anymore. With the square root, it's diminishing its effect. So if we run this, estimated number of rows 1404, 1235, and in pre-2014, you would get 4092. So slightly better, more, closer to the actual number of rows. please put your questions in the chat if I'm going too quick or if you're not following. As I said, I put enough code here for you to test some of this. And pretty much, you can do it different ways. So one, you can use a hint, even if you're not running it in 2012. If you want to see how it's going to behave, you can use a trace flag. So I use both just to show you that there are different ways to do it. I rather use the hint if I need to, than using a trace flag. So let's look at parameter sniffing. If some of you don't know what parameter sniffing is, look it up. You always get into this. Basically what it's saying, when a query is first time getting executed, the query get compiled and execute with the same parameter value that you called with. Then the plan get into the cache, the best plan or comparatively best plan, cheapest plan. And then any query that's coming with the same hash or the query hash, it uses this execution plan from the cache. Now you don't get compiled anymore, right? So if you are calling a query that just pick a number that qualifies for 100 rows for that parameter value, and next time you come and call the same query with a different value which qualifies for 10,000 rows, right? Now you have a problem because now you have 10,000 rows, you need more memory, you need more CPU power, but you are compiled with a different one which only had a small set of rows. And how do you solve it? I'm not going to get there. There are many ways depending on your situation. But how do you identify it and how does it affect during the cardinality estimation? So let's look at it. I'm creating a very simple store procedure, as you can see here, just for demo purpose. And now I'm calling this for the first time, right? Because we just created this with the 1025. And we looked at 1025 before, if you remember. 89, actual number of rows, 89. So it's all match, good. Now, I didn't do anything next time calling the same one because I need to look at a different person whose ID is 1057. It's not going to compile anymore, right? I mean, it's not going to do a recompile because it's the same hash. It's already in the cache. I don't need to go through those 4 phases that I showed you out of the 6 phase. It will, just grab the plan from cache, go to execution. Now we also looked at 1057 before. It was 118 something, right? If you remember. But look at this. We still see this 89, right? But for 1057, if we go here, we should get 118.6667, which you saw before, right? So what happened? Let me show you something here. If we go to the parameter list, and look at the runtime value. So it was compiled with 1025 because I called it with 1025, but it was executed with 1057. And that's why we still see the estimated number of rows, 89. Now, if I remove this plan from cache, this is a piece of code you might, reuse it, right? If you ever have to evict a single plan, this is one of the best way to do it. So you don't have to remove anything else. Now, if we run this, because now we evicted the plan, is going to get compiled again. Right? And just to make sure that what I showed you before, See that now compile, and the runtime is the same value. Any question? No. Unknown. So if you've been working with SQL Server for a while, I'm sure you bump into this, right? Sometimes it's just not known to the query optimizer. Why it's not known, right? So there are many examples, but I'm just going to pick few and talk about this. So one is so if we do this, I'm declaring a variable and I'm saying it's equal to 1025. And we saw 1025 before, right? Oh no, sorry, this is a different. I'm going to get there in this one. I just also sneak in something. If you have a column that's declared as a unique value, then SQL Server is smart enough. It knows that every value is unique. You do not have to do anything. You will see that the estimated number of rows are, one always. So it gets it from the metadata. It knows, so you don't have to worry about it. Next here, contact person ID is 1025. I'm passing it, but this time I'm not hard coding it, right? I'm declaring it as a variable and use it. So what will happen now? What happened? We saw this every time, 1025, we get 89. This time why we're getting 111.03? Because it's a variable. Compile time, it doesn't have any idea what is the value of that we are passing. So what it will do, again, density of contact person ID, if you remember, this number, use that number, total number of rows. That's it. So you can pass any value, all. There will be no change. It will always estimate this number. So coming back to what I mentioned a few times, it's good to know these things. So when you see this number and if it's a huge difference now, you know that because I'm doing it this way, that's why I'm getting this number, right? Table variable, another problem. So table variable, I think pre-2014, it will always estimate the number of rows as 1. In 2014, it was changed to 100. And also there is some change in 2019, which I'll talk about. So for now, I'm not going to use the option recompile. Let's run this. As you can see here, estimated number of rows is 1. Because it has no idea what's in the table variable. If we do a recompile, you will see comparably better result, right? 271.284. Now, if you're in 2019 and you have the compatibility level set to 150, you do not have to recompile. Just being into 2019, SQL Server, this is called, again, under the intelligent query processing, there is a feature named table variable default compilation. I also put a URL. If you're interested to read a little bit more about this, you can go and do that. So here you will see that without the recompile, I'm getting this number. I'm going to skip that, go back to 140. And then so where is that number coming from, right? So let's look at this. So in SQL 2014, for table variable, you get 271.3. If you're in pre-2014, this was way, way high, right? And again, this is hard-coded. As you can see, I wrote the formula. It's pretty much, raised to the power of 0.75 and raised to the power of 0.5 on the total number of rows, right? You really cannot do anything. These are all hard-coded. But it's got a lot better. Again, there may be edge case that, it can go other way. And then I put a bunch of, other operators, right? Greater than, less than, and all that. So if you run all this, you'll see the estimated number of rows for all are same, 22,078.5. So where is that coming from for all this? It's just the 30% of the total rows. You have no control. It's hard-coded. Same for the like operator. It's 9%. For between, there is a change from 16.5% to 9%. You can run all these and you'll see the numbers. So just to show you a last one. You can see that it's 6623. And I'm using the hint here. So if you're using pre-2014, or you use a hint to use the older cardinality estimator, that's really, but if you're in 2014 or above, is 12,092. Now this is a perfect example that I've been telling you for a while. Look at the actual number of rows, right? So it's really got bad in this example. So again, you just have to test it, right? It's not always guaranteed to be better with the 2014 and above with the newer cardinality estimator. So the last one, I know we are up to the hour. I'll just take a few more minutes. The ascending key is a common problem for the problem has been there. So what happens if you have your primary key or your ID or whatever, say like a date time, right? It's always increasing and you are always inserting row at the tail of the table, or you're generating new ID automatically, or it's a date time based, right? You're always inserting at the bottom. As we saw before, that just by merely inserting bunch of rows does not update your statistics. There is there's formulas, how many rows had to get modified before even your auto update stats kick in. Before SQL Server 2016, it was pretty much hard-coded 20% plus 500 rows. But after 2016, there used to be a trace flag, I think it's 2371, which based on the table size, it reduces the number of rows that will trigger automatic update stats. You don't have to use that trace flag anymore. This got built into the engine from SQL 2016. So now, if you do not, if you're inserting rows at the bottom, what happens, right? Because those are not calculated into your histogram. So how does SQL Server behaves? So let's look at this. So we know that we have 73,595 rows. We have all these stats, and then we'll use one of these, which is the date time. And if you go to the bottom, keep a note that the max date we have is 2016, May 31st. So let's insert some rows, about 50 rows, but we're going to use March 1st, 2017. So it's done. Now, just to make sure that we inserted those rows. And if we go to the histogram, we still have the max date is 2016, May 31st. What does that mean? Means these rows, the histogram has no clue about these rows, right? Because they're 2017. So now if we do a select with that 2017, what's going to happen? Inserted 50 rows, remember? it sees that 34 rows. So where is that number coming from? Pre-2014, you'll just see one. There's no calculation. It's hard-coded one row. In 2014, this is the formula. As you can see, it's got a lot better. And if you have this problem, I put a link in the resource slide. Also, there's some trace flags. If you're still using a version of 2012 or 2018 or 2005, hopefully not, read that. It might, give you some relief. So that's all I have for demo. I hope that it was useful for you and for your time. So let me go back and let me. What's going on here? Oh, I cannot. Okay, so these are the references. If you want to read more details about those, again, these are my contacts. If you need to reach out, ask any question, anything. And thank you so much. So before